Greetings, Patriots. In this lesson, we are going to now combine everything we've done all week and review rational numbers. So go ahead and take an opportunity to set up your notebook once again. You can create a table because we will be going over a few examples. We will have some true and false statements as well. The other thing that would be really beneficial for you to have is this document that we shared in one of the lessons. It was actually given to you to look at, and it would be a great reference for you as you are identifying the different types of numbers that we've been learning about and their relationships. So take a moment to stop the video and set yourself up. Okay. The learning objective for today is that we are going to review what I've learned about rational numbers. So let's go ahead and look at this first set. For each value on the left, you're going to write that number in an equivalent form. So you're going to write that in another way. Then you're going to place a check mark in the box for any set of which the given number is a member. So I'm going to, before I get started, if I have my Venn diagram that shows me the relationship of numbers, it might be a good idea that you write that now. Or draw it, just so that you have it with you. So remember, if I'm a natural number, I'm a whole number. I'm also an integer, and I'm rational. So each subset is a part of the other set, especially as I go from inner all the way out. So 93, I know another way to write 93 is 93 divided by 1. That equals 93, or 93.0. Well, according to my characteristics, natural numbers are positive. They cannot have decimal values, okay? And they exclude 0, so no 0. Whole numbers are also positive, but they include 0, and they go on positive. This starts with the number 1. Integers are both positive and negative, but all of these three do not have decimals, no decimal values, a part of another number. And rational numbers are numbers that can be written in fraction form. They're positive and negative, and they can all be written as fractions. I'm just making myself some notes as I review. So I can see that 93 meets the definition of natural numbers. It's positive. 93.0, even though I wrote it in decimal form, it's still not, I don't have a 0.1 or a 0.2. It's not a part of another value. So it's whole, because if I'm natural, I'm whole, I'm an integer, and I'm rational, because I can write 93 as a fraction. Negative 0.63. Well, I know that this for sure is a decimal value. That's another way I could write that is negative 63 hundredths. Okay, I'm a value less than 1, and there's my place value. I know it cannot be a natural number because natural numbers start with the number 1, and they're only positive. I cannot be whole because that's a negative. Integer. Sometimes we think that this is an integer because it has a negative. However, remember, no decimal values, so therefore the only possible one that it could be is rational. 0, I know 0, another way to write 0 in fraction form is 0 divided by 1. But natural numbers start with the number 1, so it can't be natural, but it definitely is whole. Again, if I'm whole, I'm integer, and I'm irrational. 56. I can write 56 as 56 divided by 1, or 56.0. It's a natural number because it's positive with no decimals. It's a whole number. I know it's an integer, and it's irrational because it can be written in fraction form. Negative 7. Negative 7 I can write as negative 7 over 1. I can even take 49 and divide that by negative 7, because that gives me a negative 7 if I remember my integers. It can't be natural, and it can't be whole because that's a negative value, and these are only positive, but it's definitely an integer because it doesn't have a decimal value, and it's irrational. 1/4 I know is equal to 0.25 or 25 cents. I can actually take a whole and divide it by 4 to get that value. If you need to remember that you can divide a fraction in order to get its decimal equivalent. Well, I know it can't be natural, I know it can't be whole, and I know it can't be an integer because no decimals are allowed in these three sets. But it definitely is a rational value. Okay, so you will have to identify using your definitions that we wrote this week. Use your graphic organizer to help you identify the value. And don't forget, sometimes it's helpful to write it in an equivalent form. Okay, let's go to, now we're dealing with true-false statements. If it says write true if the statement is true and F is the statement is false. If your statement is false, explain why. Again, I like to have my graphic organizer with me as I answer these questions. So make sure you have your graphic organizer available. All natural numbers are whole. Well, natural numbers is a subset of whole, so therefore that's going to be true because anything that's in the subset of the other means it's a part of that set of whole numbers. All integers are rational. Well, my subset of my integer family or my integer set is a subset of my rational numbers, so therefore I agree that's going to be true. Okay, because I can be an integer and also be a rational. Now it says that everything that's in the integer family, so my integers include negative values and 0 and positive values. It says all of the integers are whole. Well, I know that whole numbers are only positive values. So that word all, I'm going to say, makes this a false statement. Some integers, all right, I can say some integers are whole. The positive ones. Okay, so it says explain why. So some integers are whole numbers. Okay, not all. All right, let's go to the next one. Some integers are natural numbers. Okay, so if I think about my set of integers right here, I'm going to agree that some of them are natural values because natural values are 1, 2, 3, and so forth. And some of the integers do include those natural numbers. So therefore that is true. So again, go back to your graphic organizer and definitions of each of those sets of numbers. The real number system, here we go. Which of the following is an integer? Okay, so it's an integer. So I know an integer is positive and it's negative, no decimal values. Okay, so which of the following is an integer, but it's not a whole number? Whole numbers consist of 0, 1, and 2, and 3, and so forth. But it says no whole numbers. So it can only be an integer. Okay? Well, what Ms. King likes to do is simplify if I'm given a fraction. Well, I remember that when I divide fractions, if I have a negative and a positive, I'm going to get a negative quotient, a negative answer. Negative 15 divided by 5 is equal to negative 3. 18 divided by 6 is equal to a positive 3 because 6 times 3 is 18. 3 is just the value of 3, and 24 divided by 8 is also going to be 3 because 8 times 3 equals 24. So which of the following is an integer but not a whole number? Well, I know anything that's positive is a part of the whole number set if it's not a decimal value. So the only thing that can be an integer is negative 3 because integers includes positive whole numbers and their opposites. So this must be the answer. Finally, let's get to number 4. I've given you a set of numbers. You're going to use them more than one time. So you're going to place the numbers in each of the Venn diagrams according to their set or subset. Be sure you read and label what each diagram represents. So right here they're telling me that set A is whole numbers. I'm going to write that. These are my whole numbers, and I know whole numbers are positive values only. Natural numbers. Okay, my counting numbers. Well, I know my natural numbers start with 1 and move forward. My whole numbers start with 0 and are positive. So I also know that these values cannot have decimal values. No decimals. Notice how I'm writing my characteristics. And they can't have decimals, and they're only positive values. Okay, so negative 2.3 cannot be either one of those. Now 123 definitely is a natural number. 123 is a natural number, and it's also a whole number. 123, 123. Okay. Negative 9 cannot be either one of these. 40%, well, I'm going to convert that to a decimal. So to go from a percent to a decimal, remember that's 40 out of 100 is 40 hundredths. Okay, that's a decimal value, so it cannot go in either one of these sets. Then I have the number 0. Well, 0 is not a part of natural, but it definitely is a whole number. So again, do you see, I can write this number in its specific subset, but any other set that it belongs to. So you can use the numbers more than one time. All right, let's move on. Now we're looking at this set of numbers. Set A is rational. So I know that rational values, they can be positive, they can be negative, they can be decimal values. Set B is only integers. Okay, so if they're integers, they can be positive or negative, right? Positive or negative, but no decimal values. So on set B, I'm going to make that note, no decimals. All right, so let's look at the first number. Negative 2.3. Well, it has a decimal, so it cannot be an integer. It is negative, but the best place to put that is right here. Negative 2.3. Or I can write it in my little Venn diagram. 123, well, I know that that is definitely an integer, so therefore it's also a rational number. Okay? Negative 9 is also an integer, and it's also a rational number. I'm going to write that right here. 40% is a decimal, so it cannot be an integer, but it definitely is a rational number because I can write that as 40 hundredths. And 0 is an integer because it includes those whole numbers as well, so it definitely is an integer, and because it's an integer, it also has to be a rational number. So notice, all of these values right here were rational values, but only a few of them were integers based on the characteristics. Please make sure you're using your notes when you do this assignment. You will have to complete a short assignment reviewing rational numbers and classifying them. So, did we have an opportunity to review what we've learned about rational numbers? Yes, we did. Have a great day.